Example 9. A pipe strut BC is loaded and supported as shown in the figure. The strut has a uniform cross-section and a mass of 50 kilograms. Determine the tension in the cable and the reaction at support C. So if you can observe based on the problem, rather than just ask on the horizontal and vertical components of a certain support, this time we are tasked to find for the full reaction. So yes, of course, we will first calculate the X and Y component of our support C, and then ultimately find the equivalent resultant of the entire support at C. Okay. The first thing that we're going to do is rewrite our free body diagram. So take note that instead of not considering the weight of our structure, it is provided there a mass. So therefore, we will consider the weight in our analysis. That is, oh, okay. So we have, write our free body diagram. Okay. So at the very middle, okay, we have a going down force, which is 750 Newton. Okay. It has a perpendicular distance, which is 800 mm, right? 800 mm, 800 mm. Okay. And then our tension is always outward. So this is our B, point B. So this is our tension. This is our tension. And the distance is 1,000 meter. This is 1,000 mm. Okay, so of course, since we'll be considering the weight, we add another force going down at the centroid, W. Okay, we have, since if you can observe by inspection, we have a Y component, which is our weight and our 750. So it must be that we have a support here, C sub Y. And again, by inspection, only our tension, T, has a horizontal component, and that is going to the left. So therefore, our reaction at the horizontal reaction at C is going to the right to counteract that tension there. Okay, so what is the other unknown would be our weight. So that this W is equal to mass times acceleration due to gravity. And this is 50 kilograms times 9.81. So our weight is equal to 9.81 times 50, and that is 490.5 Newton. So if we do force summation in the Y, we will be able to get our C sub Y, right? However, if we do force summation in our X, we'll end up with two unknowns, and that is the tension T and our X component C sub X. So it is best that we do our moment summation first is equal to 0. So summation of moment at C is equal to 0, assuming counterclockwise positive. So the W and 750 all cause a clockwise moment about C, and tension is counterclockwise. So that is T times 1,000 T times 1,000 minus our 750 times the perpendicular distance, which is 800, minus 800 minus our weight, which is 490.5 times still 800, just two zeros, 800 is equal to 0. So this becomes T times 1,000 is equal to 750 times 800 plus 490.5 times 800. So our T is equal to 750 times 800 plus 490.5 times 800 divided by 1,000, that is 992.4 Newton. So this is now our value for for our tension. So since having calculated our tension, we can now we can now do force summation to get the values for our C sub x and C sub y. Okay, we do x first. Summation of forces x is equal to 0, assuming to the right is positive. Then this should give us C sub x minus t is equal to 0. So C sub x is equal to t. So C sub x is equal to whatever value we got for t, and that is 992.4 Newton. Now for our y, oh wait, don't box this one. Okay. Summation of forces y is equal to 0, assuming upward positive, and this should give us C sub y minus 750 minus our w, which is 490.5. 490.5 is equal to 0. C sub y is equal to positive 750 plus 490.5. So our C sub y is equal to 750 times 490.5 is, not times, sorry, 750 plus 490.5, that's 1,240.5 at Newton. So for our the total the reaction support, so reaction, so that is C is equal to magnitude of our reaction at C is square root of C sub x squared plus C sub y squared. This is equal to the square root of our C sub x is 992.4 squared plus 1,240.5 squared. And then the value of our C is equal to 992.4 squared plus 1,240.5 squared. And we take the square root, and that is 1,588.615,123 Newton. That is the magnitude of our reaction at C. So of course, since we have an x and y component, it must be that na po siya'y angle. So our direction of C, that is theta is equal to tangent C sub y over C sub x is equal to inverse tangent of 1240.5 divided by 992.4. Theta is equal to 1240.5 divided by 992.4. Inverse tangent 1.25, that is 51.34019,019,175 degrees. And the direction would be going up to the right. Okay. So this is our, if we try to draw that, it's, and then this is theta. This is our C. Okay, that is example number 9.